Hello everyone. Now we have to discuss the relations between power in star as well as delta connection. Okay. What is the relation between voltage in case of star? VL equals to root 3 V phase. What is the relation between current in case of delta? IL is equals to root 3 I phase. Okay. First we have to dealing with active power. We have active power, reactive power, apparent power, right? First is active power, that is real power. Okay, P. Active power, because the system is balanced. Here we are considering the system is balanced, therefore common point, the power per phase, here of course system is balanced, but first here the total real power is the sum of individual powers, that is P is equals to, finally we got 3 into V phase I phase cos phi. Here also the power per phase in delta, which is equals to what? V phase I phase cos phi. Therefore in case of star connection, P is equals to 3, it's okay. Coming to phase voltage, we can write VL by root 3, right? I phase should be IL cos phi. Therefore P is equals to what? Root 3 VL IL cos phi, right? This is the formula for real power in case of star connection. Like that, in this case total P is equals to what? 3 into V phase I phase cos phi. So P, which is equals to 3 into V phase is equals to VL in case of delta, but coming to phase current, which is IL by root 3 into cos phi. So P is equals to what? Root 3 VL IL cos phi, right? We have to write here VL is equals to root 3 V phase and IL is equals to I phase in case of star. But like that, in this case VL is equals to V phase and IL is equals to root 3 I phase. Okay. One more important point. What is this phi? Where phi is equals to what? Phase angle between what? Phase voltage and phase current. This is very important. Phi represents what? Which is the angle between phase quantities, phase voltage and phase current only, not line voltage, line current. Okay. Next, reactive power. That is Q, right? Reactive power Q. So reactive power is what? Simple. If active power is Vi cos phi, obviously the reactive power is what? Root 3 VL IL sin phi. Okay, Q is equals to root 3 VL IL sin phi. In this VL IL sin phi, right? Have to units are watts, right? Watts. Here we have what? Units are volt ampere reactive. Volt ampere reactive. Then coming to apparent power, third one. Yes. Then which is nothing but what? Complex power of 3-phase circuit, right? Which is equals to what? Yes, which is equals to P square plus Q square, which is equals to what? Root 3 VL IL. That's it. VL, sorry, root 3 VL IL. We have to write like that. Root 3 VL IL. What are the units? Volt amperes. Volt amperes. See, if you consider any power, whether it is active power or reactive power or apparent power, the formulas in any connection looks like what? Same. Of course, if you consider active power, root 3 VL IL cos phi, here also root 3 VL IL cos phi. But within that, see, there is a variation in the relation. That is, in case of star connection, V phase is what? VL by root 3. In case of delta, I phase is what? IL by root 3. That is the only difference. Okay. Now we have to get the actual relation between the powers in star and delta by considering one example. So a 3-phase load has a impedance of 10 ohms in each phase and is connected in star and delta against what? 400 volts 3-phase supply. Compare the power consumed in both the cases. So across load there is a supply voltage, that is 400 volts, that is 3-phase supply, but the load is what? 10 ohms only. Means what? Z is equals to R. We don't have any reactive elements, therefore the load is what? Pure resistive load, right? Without any delay, let's start the problem. Before that, we know that impedance is always taken per phase only. Therefore ZPH, which is equals to, we provide the value of R, which is equals to what? 10 ohms only. That is load is pure resistive load. Okay, that is phi is equals to 0, which means what? Cos phi is nothing but 1, that is UPF. Clear? Therefore the total power is what? Active power only. Therefore total power in the system is real power only. Why it is real power? Vi cos phi. Coming to reactive power, Vi sin phi. Phi is 0. So we all know that if impedance is equals to pure resistive circuit, obviously the power factor is 1. The total power in the circuit is what? Real power only. Okay, we all know that. What is the formula for real power? P is equals to root 3 VL IL cos phi, or we can say 3 V phase I phase cos phi, right? Whatever may be the connection, for star and delta connection. That's it. Okay, this is the groundwork from this problem. Now we have to calculate the actual values. Okay, but given the voltage, supply voltage is what? 400, but the examiner didn't provide whether it is line to line voltage or phase voltage. By default you have to consider it as line to line voltage, same like in case of RMS maximum values. If we provide particular thing, then you have to consider that a mentioning value, otherwise you have to assume RMS value. In this case also he didn't provide any mentioning of line to line voltage or phase to neutral voltage, therefore by default it is line to line voltage. Okay, there is no mentioning of supply voltage, right? Whether it is line to line voltage or phase to neutral voltage. Means phase to neutral means what? Phase voltage. So there is no mentioning of supply voltage, whether it is line to line voltage or phase to neutral voltage. So by default we can considering here that line to line voltage. Okay, therefore line voltage is what? Which is equals to 400 volts, right? The given supply voltage is nothing but what? Line to line voltage, that is VL equals to 400 volts. Okay, with respect to first, the load is connected in star as well as in delta. First we have to do the analysis with respect to what? Star connection. Okay, we know that in star connection VL is equals to root 3 V phase and IL is equals to I phase, right? Therefore given VL is what? 400, which is equals to root 3 V phase. From this V phase is what? 400 by root 3, which is equals to what? 231 volts. Okay, supply voltage is what? 231 volts. Given impedance per phase, which is equals to what? 10 ohms. So we have supply voltage, phase voltage, phase impedance. From this, what is the value of I phase? Which is equals to what? 231 by 10. Therefore from this I phase, which is equals to what? 23.1 amperes, right? So I phase is what? 23.1 amperes. We have phase voltage of 230 and given that impedance per phase is what? 10 ohms. So from this I phase is what? 23.1, therefore which is equals to what? IL is also 23.1 amperes. In case of star connection, IL is I phase, right? IL is I phase. Therefore the power in star connection we have to calculate. Okay, the power in star connection is equals to, by two methods we can calculate, VL IL cos phi. From this, root 3, VL is what, 400, IL is what, 23.1, cos phi is what, 1. So from this we can get the value of power is what, 16 kilowatts, right? We have all the data from this, or we can calculate, we have another formula, right? That is P in star connection, which is equals to, per phase 3 V phase I phase cos phi, 3 into what is the value of V phase, which is equals to 231, I phase is what, 23.1, cos phi is what, 1. See, what is the value? Again we have to get the value of 16 kilowatts only. You can calculate either by using that formula or this formula. Okay, finally we have got the value of power in case of star connection, that is 16 kilowatts. Okay, star connection completed. Next, do the analysis with respect to delta connection. Delta connection, right? In this, we know that VL is equals to V phase and IL is equals to what, root 3 I phase. Given that VL is 400 volts, right? This is 400, which is equals to what? In case of delta, V phase is nothing but 400 volts only. But in case of star, phase voltage is what? 231 volts. See, now you can observe the difference. By looking at the formulas, both are same, but after doing the analysis, we are going to get the value of phase voltage in case of star connection is what, 231 volts, but in case of delta connection, that is 400 volts. Okay, then phase voltage is 400 volts, like that. Given that impedance is what, 10 ohms, from this we have to get I phase, 400 by 10, which is equals to what, 40 amps of phase current. See, there we have what, phase current of what, 23.1. now we have the phase current of what, 40 amps. This is the difference. That's why I am considering this problem with respect to pure resistive load. So I phase is there. What about IL? Therefore IL is what, root 3 into 40 IL, which is equals to, what is the value, root 3 into 40, we get 69.3 amps. Then in case of delta, power in case of delta, which is equals to, first we can use root 3 VL IL cos phi, which is equals to what, root 3. What is the value of line voltage? 400. Line current is what, 69.3 into 1, which is equals to what, root 3 into 40 into 69.3 into 400. You can get 48 kilowatt in case of delta. Or we can use another formula, 3 V phase I phase cos phi. 3, what is the value of V phase? That is 400. What is the value of I phase? That is 40 into 1, which is equals to what, again 48. kilowatts, right? Then what is the value of power in case of delta? 48 kilowatts. See, in case of star we are having 16 kilowatts. In case of delta we are having the power is what, 48 kilowatts. So we have a beautiful conclusion point, that is from the above example we can concluded that the power consumed in delta connection is how many times? 3 times more, not more. The power consumed in delta connection is 3 times the power consumed in star connection. Clear? The power consumed in delta connection is 3 times the power consumed in star connection. Since from example the power consumed in star connection is what, 16 kilowatts. Power consumed in delta connection is what, 48 kilowatts. This is very important observation. The powers in star as well as delta both are not equal. What is the relation between this power? The power in delta, which is equals to 3 times of power in star. This is very important relation. Okay, this is about the relation between the powers in star and delta, right? This is the conclusion. What is the relation between power? The power in delta should be equals to 3 times of power in star.